Hi, and welcome back to Computer Technology. In the last video, we took a look at a programmable logic controller program that did sorting of different items. What we're going to do in this video is take a look at the details of the ladder logic and see how the program actually functions. First thing we'll do is take a look at the first rung, and first of all, to note, the program PLC is not running. It is in program mode, so you're not going to see any relays activated or any contacts activated. This first one here, X24, is the toggle switch that controls the conveyor belt. Once that is turned to the on position, that contact goes high and it will set Y1 output, which is this part of the conveyor, to go forward. It is also connected in this part to Y2, which is the second part of the conveyor that will cause that to go forward. The next run deals with moving the robot arm. In order to get the robot arm to move, we had to push the push button. So what this contact does is takes a look at the push button X20 input and monitors that. If that is pushed and X0 is the indicator telling us that the robot is in the starting point. If that is in the starting point, if those two conditions are satisfied, they will form an AND gate function, and Y0 output will go high. That is the command to start the robot arm in motion. Next, if we scroll down and take a look at the logic for determining the size of the object. That's what we see in these two rungs right here. We're going to take a look at some pictures first to try and figure this out. If we take a look at how we determine whether the object is large, what we have are three sensors. If the upper sensor, X1, goes high, this will be a logic 1. The middle sensor should also go high, this will be a logic 1. And the lower sensor should be high, that should be a logic 1. If all of those conditions are met, since this is an AND gate, an AND3 gate, this logic output will go high, and this will move the sorting arm to the rear position in order to allow for proper sorting. If we go back and we take a look at what it looks like in ladder logic, we see that we have X3 here, which is the lower sensor, X2 is the middle sensor, and X1 is the upper sensor. When they're written all in line, or if you will in series, that indicates an AND logic condition. If those three sensors are picked up, that will move our sorting wing, which is Y5, to the back position in order to allow our object to move in the forward bin. If we just move this up a bit, we'll take a look at the logic involved at looking at the small and medium-sized objects. It's a little more complex. If we take a look at our logic, here's what it looks like. We have two AND gates in this condition and an OR gate. In order to determine if the object is small, the lower sensor will turn on, so this will be a logic 1 or high. The middle sensor will not turn on, so we'll have to invert it in order to go into our AND gate. And the upper sensor will not turn on as well, so we're going to have to invert that. Once we do that, if this one is on, a logic 1, then this will determine that the object is small. We're going to move to the the OR gate, and with the OR gate, it will determine if one of these is high. It will swing the sorting arm to the forward position, so it moves in the proper location on the conveyor. If we take a look at a medium-sized object, if we have a medium-sized object passing X3, the lower sensor will be on, that will be a logic 1 or a high. The middle sensor will be on, so that will be a logic 1. The upper one will not be, so we're going to have to invert that and put it into our AND 3 gate, and that way that condition will satisfy this AND gate, and it will determine that the object is medium. That will move up to our OR gate, and again, if either of these is a logic 1 or high, that will swing our sorting arm to the forward position. So that's what it looks like in terms of AND and OR gates. If we look at ladder logic, here is what it looks like here. Here is the logic to determine the small size. So here is X3, that's our lower sensor. This is our invert, if you were, or invert contact, X2, and the same for X1. If those conditions are met, then that will set our sorting wing Y5 in the proper position. Here is the logic for the medium-sized object. X3 will be on, X2 will be on, X1 will be off, so we have to invert. It will look like this here, and that will in turn set our swinging or sorting arm in the proper location. Since these two, this is for the small, this is for the medium, are in parallel, that forms a logic OR condition. If we move down, X4 is for our sensor counting our large objects. So basically that input just moves to an output that controls our counter. Counter 1 will count up to 3 before it turns on our lamp. X5 is the input for the far sensor over on this side here, and every time that contact is set, that will change our counter, counter number 2. That will count up to 5, and once we get to 5, the lamp for that will turn on. Scrolling down, this here is counter number 1, and what this will do is set our output. So once the counter has reached 3 large objects, that will set Y22, which is the lamp for our large objects. Counter 2, once that counts to 5, this coil will turn on and it will set Y23, which is the lamp showing that the bin in the rear is full and needs to be emptied. The very last part of the logic is to reset each of the bins. This is a push button X22, that's push button PB3. Once that is pushed, that is going to reset our lamp so it turns off, and it's going to reset our counter, counter number 1. Once the rear bin is full, the operator is going to take things out of the bin and reset by pushing push button 4, that's at the bottom here, X23. That is going to reset our lamp Y23, and it's going to reset our counter, counter 2. I hope that explains the details of the ladder logic in this program. If you have any questions, please come and see me in class. Take care. We'll talk to you soon.